Good afternoon. Again, this is Scott Payne. This is my Math 502 final exam presentation video 2. And this is what is a Bayesian interval, an example of a Bayesian interval. And this example is not going to be a full mathematical, I shouldn't say mathematical. It's not going to have a lot of numbers in it, but I think it kind of gets to the point of kind of what is a Bayesian interval. But let's start out with just kind of a couple of things here. If we're going to talk about a Bayesian interval, I think we need to understand exactly what is a confidence interval and how those two compare. Because at the end of the day, I think it's really what we're looking at. We have two different techniques here. So a confidence interval, we have an unknown parameter. It's either going to be inside or outside a range of values. Okay, let's say 95%. It could be 98 or 90, whatever the confidence interval is. But let's say it's 95, meaning that if I had 100 samples, 95 of them, my parameter, this unknown parameter, would lie between some range of values. But the problem is I don't know what the interval is. Right? The interval can fluctuate, right? But the parameter's actual value is fixed. Right? Now we're going to contrast that with a Bayesian. Okay, so here the intervals are based off the Bayesian model, and we've seen that in a previous video that we've done. But here the unknown parameter now is a random variable, but the bounds on the interval are fixed. And this kind of leads us to the posterior distribution, which obviously Bayesian, we're going to deal with the distribution. So if we look at that next slide, and this is kind of where everything kind of culminates for me, and I'll pick this up here. Let me, if I can do this. There we go. So I sourced this. You can probably see it there at the bottom, blog.statsouls.com. But I pulled this graph because I thought the image. So I thought the image was kind of crucial here. If on the left-hand side here, we have a series of confidence intervals, 90%. Well, there's 10 of those here, and if we notice, there's one up here where this parameter lies outside of that interval. So we say we have a 90% confidence that our parameter lies within some range of values. But I don't know what those ranges are. But over on the right-hand side, now we see a typical distribution. So using the Bayesian model, posterior. So here we're building an interval that contains the true parameter with a probability of 90%. So in our the way we normally would speak is, I want to know, well, what is the probability that this parameter theta lies between two values? The credible interval is going to give me that information. The confidence interval will not give me that specific information. It just tells me of all the samples, I know that with 95%, or in this case 90% confident that the true parameter lied in the interval, but it doesn't help me to narrow down the bounds on that, right? Because each one of those can vary, the range can vary for each one of those samples. And that's all I have right there on the Bayesian interval, and we'll pick up with video 3.